Section 1 of Chapter 2 of review of graphs and functions. The first thing we want to review is the distance formula. So reminder, the distance formula, D, which represents our distance, is equal to the square root of x2 minus x1, that quantity squared, plus y2 minus y1, that quantity also squared. And all this is underneath my round. The most common mistake that I see that people make in a distance formula problem is mislabeling their points. All right? So it's going to seem very elementary, and, very simple, but I do suggest you go through every problem, make sure you're labeling the points correct. So example 1. Here we're going to find the distance between the point P, which is the ordered pair 3, -5, and Q, which is the ordered pair -2, 8. So like I said before, the first thing you want to do is make sure you're labeling your points correctly. The way I do it, remember every ordered pair, the first number is X, second number is Y, so I'll go XY, XY. This is my first X, first Y, second X, second Y. All right. You just take a second to do that every single problem. You make sure that you're not mislabeling your points. And that'll cut down on the most common mistake that I see people make when dealing with the distance form of the problem. All right, so after that, really just plug everything into its appropriate place. So we have x2 minus x1, or in this case, -2 minus 3, that quantity squared, plus y2 minus y1, or in this case 8 minus a -5, that quantity also being squared. So remember that anytime we subtract the negative like we have here, that's essentially adding. So we really have the square root. -2 minus 3 squared would give me -5 squared. Remember the sign's the same. We're really adding and keeping that sign. Plus 8 plus 5 give me 13. That quantity also squared. -5 squared would give me a positive 25. Plus 13 squared would give me a positive 169. And 25 plus 169 gives you 194. So the distance between P and Q with the respective points will be the square root of 194. Remember, that's an estimation. We plug it into the calculator to give us a decimal, but we want to keep it exact values if possible. Also want to make sure that we can't break down the square root. Now for the square root of 194, there's no perfect squares that divide to it evenly. So this is actually our final answer. Right. Any questions on example 1? Oh, yeah. All right, but any questions on this first example, though? All right. So usually the distance formula and the problems like it, not a really an issue. It's those application problems, the ones where you gotta kind of think about it a little bit. An example of an application problem for distance formula using previous knowledge would be something like this. We're asked to determine if M, N, and P are vertices of a right triangle. You can think of vertices like the corners of a triangle. So we can think of this triangle as triangle M, A, and P. We're given the points M, which is the order pair 0, -2, N, which is the order pair 5, 1, P, which is the order pair -4, 3. Now, in order for us to see if M, N, and P, these points are the vertices of a right triangle, we have to remember that if it's a right triangle, or if we're dealing with a right triangle, that means the Pythagorean theorem holds true. So what we want to do is find the distance between M and N, that's one side of our triangle, the distance between N and P, that's another side of my triangle, and the distance between M and P, that's our third side of our triangle. Keep in mind that if it's a right triangle, the longest side has to be the hypotenuse. All right, so we can start off by finding the distance between M and N. So this would be the square root. And you can think of M as my first point, N is my second. So x1 would be 0, y1 -2, x2 5, y2 1. So we'll have x2 minus x1, or in this case, 5 minus 0 quantity squared, plus y2 minus y1, or in this case, 1 minus a -2. I mean, anytime we subtract a negative, just like adding. All right, so we know 5 minus 0 would just give me 5 squared. 1 plus 2, that would give me 3. So we have 3 squared. We have the square root of 25 plus 9. 25 comes from 5 squared. The 9 comes from 3 squared. And we end up with the square root of 34 as the distance between M and N. So that's one side of our triangle. Next one we can find is the distance between N and P. So now N is the order, my first point is 5, 1, or the point N. Second point, -4, 3, the point P, or x1, N, y1, 1, x2, -4, y2, 3. So we have x2 minus x1, or -4, minus 5 quantity squared, plus y2 minus y1, or 3 minus 1 quantity squared. All right, so 4 minus 5 signs are the same. So we're adding and keeping that sign. That's going to give me a -9 squared. Plus 3 minus 1 gives me 2. So we have +2 squared. 9 squared gives me 81. 2 squared gives me 4. So we have the square root of 81 plus 4, or that distance will be the square root of 85. And lastly, what we're looking for is the distance between M and P, or x1, 0, y1, -2, x2, -4, y2, 3. So we'll be plugging everything in its appropriate place. Or in this case, we have -4 minus 0 quantity squared, plus 3 minus a -2, or 3 plus 2 quantity squared. -4 minus 0 would be -4 squared, plus 3 plus 2 would give me 5, so that would be 5 squared. -4 squared gives me 16, plus 5 squared gives me 25. But that last distance ends up being the square root of 41. Now remember, we're trying to see if these vertices given for us for this triangle forms a right triangle. We have all 3 sides, or the distance of all 3 sides. If it's a right triangle, that means the longest side has to be the hypotenuse, or the square root of 85 is my longest distance here. So that one must be the hypotenuse. So we do want to take note that the longest side is the hypotenuse. So plugging everything into its appropriate place in the Pythagorean theorem, just as a reminder, Pythagorean theorem, a squared plus b squared equals c squared. The a and b are the legs, don't matter. What does matter is that the longest side is my hypotenuse. So here we would have the square root of 34, the side a squared, plus the square root of 41, side b squared, is equal to the square root of 85, side c, which is my hypotenuse, squared. Now we just have to remember that if you square a square root, they cancel out. So we're left with 34 plus 41 is equal to 85. Put the square root and square cancel here. Same thing here. Same thing here. And 34 plus 41 gives me 75. So we end up with the statement 75 is equal to 85. We know that this statement is a false statement. We want to take a note. If it's a true statement, then we know it forms a right triangle. If it's a false statement, it's not a right triangle. So this lets me know that the vertices given do not form a right triangle. Now, had it gave us a true statement, let's say 44 plus 41, that'll give me 85 is equal to 85. If that's a true statement, which that would be, had this been 44 instead of 34, then we know that it does form a right triangle. All right. Any questions on this example? All right, next thing we do is the midpoint formula. The midpoint formula is essentially averaging 2 points and getting a point just exactly halfway in between. That's a midpoint formula. That capital M represents the midpoint. And because it is a point, that means it's going to be an ordered pair. And the midpoint formula is x1 plus x2 divided by 2. There's my x component. Y1 plus y2 divided by 2 is my y component. So we should get 2 numbers inside of parentheses as our final answer for the midpoint. All right, an example of this, we're given the point P, which is the order pair -7, -5, and Q, which is the order pair -2, 13. And we're trying to find the midpoint given these 2 points. Just like before, the only thing that you really can mess up here, even if you mislabel your points, is that you forget that X comes first and Y comes second. All right. So this is X, Y, first X, first Y, second X, second Y. All right, so for our midpoint formula, we're supposed to take X1 plus X2, or in this case, -7 plus -2, divide it by 2. Then we're going to take Y1 plus Y2, add them together and divide them by 2. Or in this case, -5 plus 13 divided by 2. -7 plus a -2. Signs are the same, so we're really adding and keeping that sign. It's going to give me -9/2. -5 plus 13, signs are different. We're really subtracting, keeping that sign. I'll take the sign of the bigger number, should I say? So -5 plus 13 gives me a +8/2, which reduces down to 4. So my midpoint, -9/2, +4. Any questions on that one? So midpoint formula pretty straightforward. If they give us 2 endpoints, find the midpoint, we just plug everything into an appropriate place. Another type of problem you'll see is if we're given the endpoint and the midpoint, and we can find the other endpoint. So here we're asked to find the endpoint Q. P is the order pair now 8, -20. And our midpoint, M, is the order pair 4, -4. So what we have to understand here, because they gave us the midpoint, we understand the formula of the midpoint. What we're really looking for is that point Q, which we do not know. So we just call it the order pair X, Y. That's what we're looking for. We do know because of the midpoint formula that we took the X component from P and added with the X we're looking for. Let's say X plus 8. Divide that by 2, that'll give me my X coordinate in my midpoint. Even though we don't know what the point Q is, we do know if we take X plus 8 divided by 2, we should end up with 4. Same thing for the Y component of my midpoint. We don't know what the Y component of Q is, but we do know that if we were to take that Y component that we're looking for and add a -20 to it, divided by 2, it should equal -4 of the Y component of my midpoint. So now we have two equations that we can solve for X and Y, put them together in the order pair. That is the point Q that we're looking for. All right, so the first thing I would do to solve for X, multiply both sides by 2. It's going to give me X plus 8 is equal to 4 times 2, which is 8. Now subtract 8 from both sides, which lets me know that the X component for that point Q that I'm looking for is going to be 0. Same thing here. First thing I'm going to do is multiply both sides by 2. Just trying to get Y by itself. Y plus a -20 is the same thing as Y minus 20. It's equal to -4 times 2, -8. I can just add 20 to both sides, which gives me a Y of 12. So that point Q that I'm looking for, the order pair, be the order pair 0, positive 12. That's what Q would have to be if given that point P is the order pair 8, -20, and my midpoint is 4, -4. Any questions on that example? The hardest part of that second is really just understanding how the midpoint formula works and setting up those two equations. After that, really just solve the equations. Next part, order pair solutions and plotting points using the X and Y intercepts. So this should just be one big deal. If not, this is an opportunity to learn for the first time. And this is something that's important. Keep in mind too, everybody should have a graphic calculator. There's no rule saying you can use your graphic calculator to check what you already know. All right, so order pair solutions. An equation. And when we're graphing, you want to at least have 3 points at the least. So we want to pick any numbers. Because technically X is an independent variable, so you can pick any value. So why not pick ones that are easy to add, subtract, multiply, divide, and give us the behavior on each side of the Y-axis. So here we're going to be picking the values -1 to 0 and 1 for our X, to find the corresponding Y, which make it a little easier for us to graph. All right, so if we're graphing the equation Y is equal to -2x plus 5. Obviously, remember slope-intercept form. You can graph out of this, or you can graph this pretty easily. But because we want to graph plotting our points, our finding points and plotting, we're going to pick our X values, like we said. I'm going to pick X to be -1, 0, and 1. Run it through our equation. Here, Y is equal to -2 times -1 plus 5. Or we end up with 7, which means our order pair on this graph be the order pair -1, 7. When x is -1, y is 7. Same thing with 0, -2 times 0 plus 5, which is going to give me 5. Or the order pair 0, 5 is on my graph. And lastly, doing the same thing, +1. And we end up with -2 times 1 plus 5, which is 3. Or the order pair 1, 3, also on my graph. So we're sketching this graph. Plotting the points, -1, 7, 0, 5, and 1, 3 to graph the line for the equation y is equal to -2x plus 5. All right, so our first order pair, -1, 7, we're going to go to the left 1, up 7. That's going to be a point on my graph. 0, 5, left, right, 9, up 5. It's also a point on my graph. And then lastly, the order pair 1, 3. To the right 1, up 3. Also a point on my graph. Now, technically, we only need 2 points to define a line, but the more points that we have, the more accurate our line. So the graph of y equals -2x plus 5 will be the line here. So this is true for linear functions, or graphs that are aligned. It's also true for parabolic functions, or graphs that are parabolic. So if we're given the equation y is equal to -x squared plus 1. And I'm going to use the same technique to graph this parabola as well. So we're going to pick our x values, -1, 0, and 1, just like we did before, running it through the function to see what the particular y values are that are associated with it. So plugging in -1, y is equal to a -1 squared plus 1. It's going to give me 0 for my y value, or the order pair -1, 0 would be on my graph. Doing the same thing with 0, replacing every x in the equation with 0, we have a -0 squared plus 1, which gives me an output of 1. We're going to have the order pair 0, 1 on my graph as well. And lastly, doing the same thing with +1. We have y is equal to a -1 squared plus 1. We end up with 1 again on my graph. So this order pair will be 1, 1. Oh, I'm sorry, that should actually be 0. I don't know how I got that 1. So -1 squared, that negative forces this 1 squared to be negative, or 1 squared gives you +1. This gives me a -1 plus 1, so this should actually be 0 here. I apologize, which gives me the order pair 1, 0 on my graph. All right, so we're sketching this graph, which is y is equal to -x squared plus 1. We know the order pair -1, 0 on my graph. So go to the left 1, up or down none. That's a point on my graph. The order pair 0, 1 on my graph. Left or right none, up 1. Also a point on my graph. And 1, 0 to the right 1, up or down none. Also a point on my graph. So we connect those dots. It's giving me a parabola facing downward. Oh, this is the graph of negative x squared plus 1. Also, a good idea to use a graph calculator to make sure that the graph you plotted matches the one that's in the calculator. Just be sure that you're plugging in exactly as you see it. Any questions on those two examples? All right. And we have 3 more examples, graphing by plotting points. This time I'm going to take advantage of x and y intercepts. So my first step is find the intercepts. Keep in mind that our x-intercept implies that y is equal to 0. My y-intercept implies that x is equal to 0. Second step, I want to find additional order pairs. And our last step, I want to plot and join the points. All right, so for our first one, we're going to graph y is equal to 4x minus 1. All right, so remember with our x-intercept, this implies that y is equal to 0. Or we'll be solving 0 is equal to 4x minus 1. If we're to solve that, that's going to give me x is equal to a positive 1/4. Just add 1 to both sides, divide both sides by 4, which means that the ordered pair 1/4 and 0 is going to be on my graph. For the y-intercept, remember that implies that my x is equal to 0. Or we'll be solving y is equal to 4 times 0 minus 1. On my y-intercept will be -1, or the order pair 0, -1 also on my graph. So we have our x and our y-intercepts. For the additional point, we could take x to be equal to 1 and then solve for y. So if x is equal to 1, we're solving y is equal to 4 times 1 minus 1. 4 times 1, 4 minus 1 is 3, or the order pair 1, 3, also on my graph. All right, so if we're graphing this, my x-intercept, that order pair 1, 4, and 1. Remember, this is 1 unit. That's a half unit, a fourth. It'll be about right here. Y-intercept is the order pair 0, -1. So left or right none, down to -1. And our additional point we found with the order pair 1, 3. So we go to the right 1, up 3, also a point on my graph. Like I said before, we really only need 2 points to establish a line, but the more points, the more accurate your line. So this would be the graph of y is equal to 4x minus 1. All right, the next example, we're going to graph y is equal to x squared minus 4 this time, which we know this graph should be parabolic in nature. Just like before, we're going to start with our x-intercept. Remember, x-intercept implies that y is equal to 0. So we'll have to solve 0 is equal to x squared minus 4. This is a simple quadratic like we saw before. This is going to give me 2 solutions. X is equal to both positive and negative 2. For the y-intercept, remember that implies that x is equal to 0. Or we'll be solving y is equal to 0 squared minus 4. Or we end up with y is equal to negative 4. So this is actually 3 points because we have 2 x-intercepts. First x-intercept being 2, 0. Second x-intercept being negative 2, 0. And my one y-intercept would be 0, negative 4. All right, so we're graphing this. Our first order pair, 2, 0, means we're going to go to the right 2, up or down none. This is a point on my graph. Second x-intercept is the order pair negative 2, 0. So we're going to go to the left 2, up or down none. Another point on my graph. And my y-intercept is 0, negative 4. So we're going to go to left or right none, down 4. And this is enough for us to sketch the graph of the parabola, which represents the equation y is equal to x squared minus 4. All right. And the last one that we have, we're still taking advantage of x-intercepts and y-intercepts, the absolute value problem. This is one you want to remember that for absolute value, the graph should look like a V. I always tell people just V for value. So if you see absolute value in your equation, the graph should look like a V. Anybody still copying this? All right, so here, given y is equal to the absolute value of x plus 1. I'm going to graph that, starting with our x-intercept. All right, x-intercept implies that y is equal to 0. So we'll be solving 0 is equal to x plus 1. Remember, with absolute value equations, we're supposed to account for both the positive and the negative. Remember, 0 is neither positive or negative, so it's just going to be one solution. All right, so my x-intercept is actually negative 1. Y-intercept implies that x is equal to 0. So we would end up with y is equal to the absolute value of 0 plus 1. We know 0 plus 1 is 1. The absolute value of 1 is 1. So my y-intercept will be positive 1. And this time we actually have to find 2 additional points. All right. So the next one that we'll find that we'll take x to be equal to 1, which means we'll have y is equal to the absolute value of 1 plus 1, or the absolute value of 2, which is, we know, is positive 2. The other additional value, x is equal to negative 2. Means y is equal to the absolute value of negative 2 plus 1. Negative 2 plus 1 gives me negative 1, and the absolute value of negative 1, positive. So for our collection of points, my x-intercept, negative 1, 0. My y-intercept, 0, 1. And I have 2 additional points. First additional point is the order pair 1, 2. Second additional point is the order pair negative 2, 1. A logical question is, well, why did we find 2 additional points here when every other time the most we found was just 1? And if we start graphing it, you'll see why. So if we're graphing this one, my first point, negative 1, 0. So I'm going to go to the left, 1, up or down, none. That's a point on my graph. Second point, 0, 1, left or right, none, up 1. That's another point on my graph. And if we only have 1 additional point, after we found the x and y intercept, the next additional point will be 1, 2. So to the right, 1, up 2, another point on my graph. Now this graph looks linear with those 3 points. But us finding that second additional point, seeing what happens to the left, leftmost point, or the left of the order pair, negative 1, 0, we see that that order pair is negative 2, 1. So we go to the left 2, up 1. And that's where we get that V shape from. So a big hint is that absolute value of x plus 1. We know the shape of this graph should be a V. So if we only found 1 additional point, it would make it look linear. And now that graph would be incorrect. So we have to use what we already know. And in anticipation of what to expect for the graph and function. All right. Any questions on this example? So I'm going to post the homework problems for 2.1 on Blackboard today. It's not due until we get ready for our next test, but just keep in mind that this is the only section that we're going to have for week 4, so it's not going to be a whole lot for that homework section on Blackboard. All right. We should just. Did I pass the roll out today? All right. Be sure to sign the roll for being here today. If you don't have any questions for me, I'll see you guys on Monday. I'll probably put them up tonight. So just check Blackboard for your results. Yeah. Over.